Okay, 2.8. We skipped 2.7 because it was more applications, pretty much more of the same stuff. So 2.8 is linear inequalities. All right, so linear inequalities we're going to treat exactly the same as linear equations as far as solving them. So the same properties hold as far as the addition property for inequalities. If I add a number to both sides, then it's not going to change that inequality. Whatever was less than the other is going to stay that way. The only difference is going to come when we're multiplying by a negative. So if we look at your book, at the beginning of 2.8, they've got this box right here that says the addition property for equality. It looks exactly like the one for for inequalities, which looks exactly like the one for equalities. So if A is less than B, if I add the same number to both sides, then it stays less than, all right? Nothing's going to change. The difference comes on this side. On page 141, this box right here says that for any three algebraic expressions A, B, and C, that if A is less than B, all right, it stays less than if you're multiplying by a positive. But if you multiply by a negative on both sides, it becomes greater than, all right? And it's not necessarily that it becomes greater than, it's just that it flips. Okay, we switch the sign. So if it was greater than, now it's less than. If it was less than, now it's greater than. And people ask me why this is, right? So why do we have to do this? Why is it different? The best way I can show you or explain to you in a few minutes on a video is if you think of the number line, all right? And we have points 1 and 2 and -1 and -2. All right, the way we have to think about this number line is that 0 is kind of our center point. We're going to be flipping back and forth over 0. So if I start with the inequality that 1 is less than 2, obviously we know that that's true, all right? So this point right here is less than this point. Now if I multiply by -1 on both sides, I'm not changing the value of anything, right? So I multiply by -1, so now I would have -1 is less than -2. So if I don't change it, I leave it the way it is. Now I'm saying that -1 is less than -2. But we know that that's not true, okay? So what you've got to remember is that we're not sliding these this way. We're flipping them over 0. So since we're flipping them over 0, I have to flip this sign and say that now -1 is actually greater than -2. If, however, I multiply by a positive, so let's say I multiply both sides of this by 2, now I have 2 is less than 4. I'm just basically spreading these out and moving them in the same direction across here, right? So I'm just scooting this one up to this spot, and I'm scooting this one up to this spot. Clearly, 2 is still less than 4, all right? But if it's a negative, we're flipping it over, all right, the 0. So that's why it switches back and forth. I hope that makes sense. I have no idea if it does, but it does in my head, and that's half the battle. So if we look at just some very simple examples, let's see. So let's look at these two examples. We have 3a is less than or equal to 18, and then -3a is less than or equal to 18. So obviously I have to divide by 3 to isolate that a. So this is 3 is less than or equal to 6. It stays because this is positive. All right. On this one, I'm dividing by -3. So I have a is greater than or equal to -6. All right. Because I'm dividing by a negative, the sign switches. Now, one area that for some reason causes people to have issues, let's look at one more example. 3a is less than or equal to -18. Okay, so I'm dividing by 3, divided by 3. So I have a, and I know this is going to be -6, but what do I do with this sign? People will get confused and they say, well, I'm dividing, but there's a negative, right? So I'm dividing, there's a negative involved, so I have to switch the sign. Okay, that is not true. If this is negative, we switch the sign. If you are dividing by that negative, you switch the sign. If you're dividing by a positive, you're multiplying by a positive, the sign stays the same. It has nothing to do with whether or not this number is positive or negative. It has everything to do with whether this one is positive or negative. Other than that, we treat these exactly the same as we treat equations. If we add something to one side, we have to add it to the other. We're trying to isolate variables. So nothing changes except if I'm multiplying or dividing by a negative. And in that case, I have to switch the sign.